Now we have arrived at the troubleshooting section. The first step is to find which PowerShell script is being used, and to confirm results on Windows devices. So let's say we monitor this Windows device by this system. There are two types of PowerShell apps. Some are native PowerShell that have PowerShell in the type. One of the examples is BIOS configuration app, so we will wrench that. You can see it doesn't use any caching, and the collection objects are retrieved by name, manufacturer, and version. And that's using this PowerShell request. So for example here, BIOS Details app is using this Windows Server BIOS configuration and it's retrieving name. Here you can reach this PowerShell request. Copy this out. Go to the PowerShell. And you'll need to normally log in as the user that you use for monitoring in SL1. Copy this and paste in here. Here you can see what the name returns if the app would collect manufacturer, version, model and make. Some of the applications rely on other applications to collect and cache data on a collector. For example, we are using caching for CPU configuration. So this application doesn't have PowerShell request here, but it says it's consuming the cached results, so it's dependent on the other app. In this case, let's say we're looking at the model. If we look at the PowerShell request, you will see that the request is in this application, Server Configuration Cache, and Windows Server CPU Configuration. So you need to go to that cache app. And here we go. We have Server CPU Configuration. This is the PowerShell request. You need to copy. Then paste in here. Enter. And here you go. So in this case, it is the name that is being used for that collection object. Here's how you can confirm what is actually being collected and what it looks like on the device side. In this video, we will be checking the certificate used for WinRM. Now we are going into the encrypted option. When the encrypted option is used, you need to make sure that the certificate is not expired. So on this machine, we ran this. And that should give you the thumbprint. This one is 46 AD. Which is this one? If you look at the certificate, you can go to the certificate store. And that will be computer certificate. It's in the personal store. You see that this is just DC. So it is just local. Which is the second one? If you look at the details, properties, see if this is 46 AD in this case. Now we need to make sure that expiration date is not passed. So in this case September 20th, 2024. And at the time we are recording the video it is October of 2023, so the expiry date looks good. That's how you check the certificate. In this video, we will cover which commands we can use from collector side. We have an all-in-one here. EM7 admin here. Let's see which command we can use. First of all, the requirement is to make sure that port 53 is open towards the DNS server. So in this case it happens to be 176. It is open. Next, make sure that the domain controller is reachable on port 88. So this happens to the same machine. The Kerberos port is open. We are going to monitor this machine. We also need to make sure that 5985 or 5986 is open here, depending on whether we're using unencrypted port 5985 or 5986 for encrypted communication. So we'll do that and see that both are open. So we can use either encrypted or unencrypted. Now let's test the DNS server. NS lookup. I can see the monitored device IP 64.176. That's the device that we're going to monitor. That works. Now reverse DNS lookup. So that is NS lookup against the name. And that one works. Now let's test the Kerberos authentication. The command is kinit and then whatever user you're going to use. So let's say we're going to use PowerShell user and at the domain name. The domain name should be all in caps. So let's type silotest.local. All right. So now if we hit enter, it'll ask for the password. Put it in. You see it didn't complain. If we'll do klist, you will see that we successfully got a Kerberos ticket. Let's run kdestroy. And then klist. So no tickets there. Let's do the same thing, but this time I'm doing the incorrect password. Now see, it will come back with some error message if there is an issue with Kerberos authentication. Or getting the ticket from the domain controller. These are the common commands that you would use. The other command that you can use is systemctl status PowerShell _collector. This is the concurrent PowerShell collection service. You need to make sure that it's running and active and there are no error messages in here. You can also check this service using Docker commands, as it is containerized service using Docker. You can do Docker ps, and let's maximize this window. Here the Docker ps should look better. You see the version of the PowerShell collector that's being used. This is something that would be useful when opening a case with us. The other thing that is helpful is a system status script that will do the overall health check of the collector. And that is useful for us because it shows the SL1 version, how many devices, and hardware configurations. So this one is pretty handy when opening your cases. And it may also highlight any kind of issues that you may have on your collector that need to be addressed. In this video, we will be covering what to collect. Now we want to collect PowerShell-related cases. We would appreciate all the details about all the troubleshooting that you have already done. And there is a PowerShell troubleshooting guide available if you'll search for that. Here is an enhanced troubleshooting guide for PowerShell. If you'll follow the guide, in many cases you will be able to resolve it on your own. But you should document all the steps that you've performed through this KB, and share that with us when opening an incident case for any additional troubleshooting assistance. In addition to that, what would be beneficial is to get the correct PowerPack version. In essence, the PowerPack version you are using. If you'll go to Application and you have a particular issue with a particular app, let's say Microsoft and Windows. Perhaps you have an issue with CPU performance, for instance. This one is Windows Server PowerPack. So provide the name of the app. Provide the name of the PowerPack. For instance, this one is Windows. Provide the version of the PowerPack. Tell us if it is happening with a single device or all devices. Provide relevant information like screenshots of a device and credentials. Anything special with the monitored environment. Let us know any changes that are made to SL1 within a Microsoft environment, and let us know the output of a credential test. Look at the credentials, provide information about the credentials. A screenshot should work. as it shows us how the credentials were configured. For instance, it shows us the type of user that was used, whether it's encrypted or not encrypted, or whether the timeout is correct or not. So with the credential, it's also useful to provide the output of the credential test. And on the device itself, you can run the app and debug on the Collections tab by clicking on the lightning bolt next to the app, then copy-paste the output of the run into the case. Here is the debug run. In the debug run you can see if the collection completes, which values are collected, whether concurrent PowerShell was used or not. As you can see here, oftentimes when PowerShell collections fail, there are some events or log messages in the Logs tab. If you see any of that in the Logs tab, please capture that and attach to the case. For instance, any information or screenshots of the device, Collections tab, Logs tab, or Properties tab will be very helpful in showing us which version is being used. SL1 version, PowerPack version, Dynamic App version, version of the Windows credentials used for the monitoring. All that information is useful. The more details you provide, the easier it is for us to get to a resolution faster. I want to share some additional tips and recommendations. Kerberos authentication is sensitive to time on collector domain controller and monitor device. So we can go to the domain controller, get a ticket, then use that ticket to go to monitored device and authenticate. If the Kerberos authentication is not working, make sure that the time on the collector and the domain controller and the monitored device is correct. There are some issues with underlying host devices imposing time on the guest devices, but it corrects itself quickly, so it may be looking like an intermittent issue. So a good troubleshooting step would be to check the time on the underlying host device to see if that Windows device is a virtual machine that is being monitored. Secondly, Windows 2008 and 2012 may not support newer TLS versions out of the box. In version 12.1.0 and higher, we are required to use TLS 1.2 and higher in order to communicate with devices, especially as other protocols are not always secure, and as a result, the less secure ciphers are disabled. The communication with Windows 2008 and 2012 may not be possible when using the encrypted option. So you might have to reconfigure those devices to allow unencrypted. Keep in mind that Windows 2008 is end of life back in 2020, and 2012 is end of life on October 10, 2023. If you don't use certain applications, or don't require to collect data by some of the app, please disable those apps. That will help to keep the database size in control and eliminate CPU cycles across your appliances. If you have all the applications already aligned during the initial discovery, you may want to disable dynamic discovery. That should spend CPU cycles on collectors on dynamic discovery. You can use a device template to disable dynamic discovery on multiple devices in bulk. Here is how you do that. Go to Device Registry. Select your devices. Pick Modify by Template. And here, activate and deselect Dynamic Discovery. Then hit Apply and Confirm. When you go to the device, you can see that Dynamic Discovery flag is deselected. This should help avoid any load issues during nightly rediscovery and will avoid dynamic discovery on devices that already have all appropriate apps aligned. That is the end of our video series. Thank you for your attention, and happy monitoring.